At the local arcade, you need to purchase a game card to play games. There's a one-time fee of $2 to get that card, and then every game that you play is going to cost 75 cents each time. So we're going to go ahead and let X represent how many gameplays there are, and go ahead and let Y represent the total amount of money that you spent at the arcade. Alright, so we're given this linear equation to represent this scenario. So we have Y is equal to 0.75x plus 2. And this is going to represent the relationship between how many gameplays that you have and the total amount of money that you spend at the arcade. Alright, so for this first part it says, what is the coefficient represent? Well, the coefficient in this linear equation is going to be 0.75. And this essentially just represents the cost per gameplay. Now, what about the constant term? Well, the constant term in this linear equation is really just going to be that 2 that we see, because that term value is not going to change. This fee represents the one-time fee for the card, and you don't have to pay this ever again. Now, as for the variable term here is going to be 0.75x. This variable term of 0.75x really tells you the total cost that you have depending on how many gameplays that you have, and this amount of money that you're spending has nothing to do with that one-time $2 fee, so it doesn't have that in consideration. Alright, let's go ahead and see in number 2 if we can go ahead and fill in this data table given some different values of X or some different number of gameplays. So let's go ahead and write these equations down. For the first one, we have Y is equal to, it's 0.75 multiplied by what? Well, it's normally going to be X, and then we have to add on that $2 one-time fee. But in this first one here, we're saying we know it's going to be 3 gameplays, right? So if we go ahead and multiply 75 cents by 3, 75 cents plus 75 cents is $1.50. $1.50 plus another 75 cents is $2.25. So this is going to be $2.25, or you can go ahead and multiply that on your own if you would like to. But if you go ahead and add on the $2 here, this is going to be a total of $4.25. So that's going to be the total cost of you going to the arcade if you were to have 3 gameplays. Now let's see, what if you had 6? Well, again, it's 75 cents for each time you play a game, but this time you're going to be playing 6 different games. So 6 multiplied by that 75 cents. Well, this should just be double of what we had before, or another $2.25. So I think this is going to be $4.50 here, plus the $2 that we have to pay for that game card. So I think this is going to be a total of $6.50. So I think it's going to be 6.5 here. For the third scenario, what if we play for 9 times? Well, again, it's 75 cents per gameplay. We're going to be playing 9 times plus the $2 that you have to pay in the beginning to get the card. And so this should hopefully make sense that it's another $2.25 on top of this. But again, if you want to multiply 75 cents by 9, you can do that. But I think this is going to end up being $6.75, if I'm not mistaken, plus the $2 you had to spend on that game card. So I think this is going to be $8.75. So this would, I think, be the total cost if you're going to play 9 different times. What about if you play for 12 times? Well, it's going to be Y is equal to 75 cents. You're getting 12 gameplays out of this one, plus the $2 you have to pay for the card. Let's go ahead and put 12 inside here. Well, let's see. I know 75 cents times 6 is $4.50, so 75 cents times 12, this should be double. So in terms of that cost, I think it's going to be $9 plus the $2 you had to pay for that game card. I think this is going to be a total of $11 here. Okay, and then one final scenario, we can say Y is equal to, it's 75 cents for each gameplay. We're going to have 15 here plus that $2. So let's see, it's going to be $2.25 more, I think, is what we've just been saying each time we go up 3 more gameplays. So if we add on $2.25 onto 9, I believe that's going to be $11.25. Again, you can go ahead and write out the multiplication if you'd like as well. But this total should be, I think, $13.25. So I believe that's going to be the total cost here. All right, next for part 3. This one's pretty straightforward here. It just says to go ahead and write 5 ordered pairs that we determined from the linear equation table. So one ordered pair, the first one is going to be 3, 4 and 25 hundredths. That's our first ordered pair. The second one is going to be 6 comma 6 and 5 tenths. The third ordered pair here we found out was 9 comma 8 and 75 hundredths. The fourth ordered pair I found out is going to be 12 comma 11. Just a couple of integers there, our whole numbers. And then the final one that we have is 15 comma 13 and 25 hundredths. So these are our 5 ordered pairs that we came up with. All right, let's see. For part 4, it's saying explain what the ordered pair when you had an x value of 6 represents. So if we go ahead and look back and see when did we see x was 6, well, that was over here. That was 6 comma 6.5. You can also see that located right over here. Let's go ahead and write that ordered pair down and say it's going to be 6 comma 6.5. Well, what did our variables represent again? Well, we knew x represents a number of gameplays, so we can say something like when you have 6 gameplays, comma, what did y represent again? I think y was the total that you ended up spending at the arcade. You can say here that you spend a total of $6.50. So that's what that represents. For this next part, it says in question 5, explain what the ordered pair with an x value of 15 represents. So you can look at 2 different locations here. If you want to look at the table, you can look at it up here. That's fine. It's 15 and then 13.25. So you can also see the ordered pair here. So you can see it in 2 different ways. So 15 comma 13.25. I'm just going to go ahead and copy that down. 15 comma $13.25. That's what that is. And so what does this mean? This represents that when you have, or when you play, you can say whichever one, when you have 15 gameplays, you end up spending a total of $13.25. So that's what that represents. All right, for question 6 or part 6, we're going to go ahead and graph the linear equation on this coordinate plane that we have over here. And so let's go ahead and take a look at our ordered pairs. We have 3 comma 4.25. So I'm going to take this dot and put it at the origin first. Let's go ahead and move it. So we're going to start at 3, and then we have to go up to 3 gameplays. We have to go up to $4.25. So here's $4, here's $5. So $4.25 must be like a quarter of a box. So something like that would make sense. Okay. What's the next ordered pair? I think it's going to be 6 comma 6.5. So let's go ahead and move this dot here. Let's go over to 6 gameplays. If you play 6 gameplays, it'll be a total of $6.25. Or no, we said $6.50. So here's $6. Here's $7. $6.50 would be right in between those two. Actually, I think I could go a little lower, maybe something like here in the middle, right? Let's see if we have our third ordered pair. That's going to be 9 comma 875. So let's go ahead and put an ordered pair here. Let's go over to 9 gameplays. Here's 9. And then what was it? It was $8.75. So here's $8. Here's $9. I think $8.75 would be right around here. Okay. Let's see. Next one is going to be 12 gameplays for $11 total dollars. So let's go over. Let's see here. Let's go over to 12 gameplays. Let's go all the way up to $11, something like right here. That one should be pretty nice. And then I think the final one we have here is going to be 15 comma 13.25. So let's see here. Let's go to 15 gameplays. And we said it was what, $13.25. So here's $12. Here's 13. $13.25 would be a little bit higher here. Now let's go ahead and just draw a straight line through these the best we can. You can use a ruler. Notice it does hit this y value of 2, which kind of makes sense. If you don't play at all, you still have to pay $2 to get that card, right? So that hopefully makes sense. And you can extend this line as well and say this is going to go on forever in this direction here. You can kind of keep on playing if you'd like. So this right here would be our graph for this linear equation. All right, so let's take a look at number 7. It says use the graph above and sketch a horizontal and vertical line to determine how much it would cost you to play 11 games. So let's see. So we're talking about 11 games here, so that's going to be along the x-axis, right? So let's go to 11 games. So here's 9 games, 10 games, 11 games. So what we're going to do here is we're going to go ahead and draw a line up from 11 all the way up to when we hit this graph, right? And once you hit the graph, we're then going to draw a horizontal line over to the y-axis here. So I'm going to draw something that looks something like this here, and we've got to figure out what this total cost is going to be. Now, if we look at this ordered pair here, it does look like it's going to cost a little more than $10, right? So I believe if X here is going to be 11, which is basically saying we're going to get 11 gameplays, I think if we're going to go ahead and say how much it's going to cost, I think it's going to be $10.25. It's kind of hard to know for sure because it's a bit of an estimate. But what you can do here is you can also check the equation and say, well, what would Y be equal to if we plugged it into our equation? Remember, our equation is Y is equal to 75 cents per gameplay plus the $2. So this would be 75 cents per each of these 11 gameplays plus that $2 here. So I guess the question is, what is 75 cents times 11? So you can go ahead and do that multiplication, but if you take 11 and multiply by 0.75, you're going to get $8.25. And if you add 2 on, you're going to end up with this $10.25. So while the estimate we were kind of just like hoping it was that value, but everything is multiples of 25. So I didn't think it was going to be 50 cents or 75 cents. It looked definitely closer to 10 here. So what does this mean? Well, we can write the ordered pair as 11 comma 10.25. We just kind of verified that. And we can write the conclusion that 11 games would cost a total of $10.25. All right, one final question. For number 8, it says use the graph above and sketch a horizontal and vertical line again to determine how many gameplays you would have if you spent a total of $6.50. So let's see here. Let's look for a total cost. $6.50 is going to be along the y-axis here. So here's $2, $4, $6. Here's $8. Here's $7, right, in between 6 and 8. So $6.50 must be in between these two lines here. So let's see. Let's go ahead and just draw a line, a horizontal line, until we hit the graph here, maybe something like this. And let's go ahead and draw this line down. So this one actually is one of the points that we put. So this one's actually quite nice here. So we can go ahead and say, okay, we know that Y here was equal to 6.5. That was a cost. And we said, okay, if we went ahead and found that it was actually X was equal to 6 when that happened there. Okay. If you want to check this, you can definitely go ahead and plug it in if you'd like to, but we can see here that hopefully that when X is 6, when you have 6 gameplays, it's going to cost $6.50. Okay. You can also plug this into the equation just to double check here, but I promise it does work. And so what's the conclusion that we can make here? We can conclude that 6 games would cost a total of $6.50, and there's tons more combinations you can go ahead and find on the graph if you would like to. If you wanted to see how much it would cost for 13 games, you could go ahead and draw a line up all the way to the graph here and then figure out the total cost looking at the y-axis here, or even for like 18 games, you can make a prediction for the future as well that it would cost a little under $16. So you can use this graph as well. It's a nice visual to find out any cost and as well as for any amount of gameplays. So there you have 8 different practice problems to help you kind of understand how linear equations and linear relationships work, where we dealt with, on the beginning, just kind of understanding the parts of the equation, and then looking at how to represent in a table and how the tables can be represented as ordered pairs, and then knowing what the ordered pairs represent, and then throwing it on a graph and how to interpret it. So hope you found the video helpful in understanding these just a little bit better. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.